Part two, probability of simple events. So let's talk about number cubes, aka dice. Which horse will cross the finish line first? There are 12 horses right here. It is numbered from 1 through 12. If I roll a die and another die, or a dice, if I roll the dice and I find the sum of it, if I find the sum of it, and the horse will move. For example, this rolls at 4, this rolls at 2. The sum is 6. So which horse number do you think will reach the finish line the quickest? So which probability? It's all about probability. This is odds of winning. I say, I don't know, 6 might win. So let's try it. So I roll. I got 5 and 2 is 7. 7 is in the lead. I rolled 3 and 3. 6. Yes. I roll 4 and 3. 7's in the lead. I roll 1 and 1, which is 2. I roll 1 and 6 is 7. I roll 5 and 3, 8. I roll 4 and 1, 5. I roll 3 and 4, 7. I roll 6 and 4, 10. I roll 5 and 1, 6. I roll 1 and 6, 7. I roll 3 and 4, 7. I roll 3 and 6, 9. I roll 1 and 6, 7. I roll 3 and 4, 7. Oh, we're going to stop. 7 is by far the fastest horse. So the sum of 7 from this through our experimental probability, which we're going to learn today. Experimental means you're actually doing an experiment. You're actually sitting and doing something to get the probability. 7 seems like it's the winner. Why is that the case? How come 1 never moved? How come 12 barely, well, maybe not, is unlikely to move, but I know 1 is impossible. Well, let's talk about the probability. Why do certain horse numbers win compared to other horse numbers? As you can tell, the middle right here is in the lead, while the extremes do not. Why is that? Well, list all the possible outcomes if you roll the first number cube. Well, when you roll the first number cube, the possible outcomes are 1 through 6. List all the possible outcomes for the second number cube, 1 through 6. We use a 6-numbered number cube. Create a table of possible outcomes for rolling the number cube. So, taking your first number cube, what are the outcomes? It's 1 through 6. Taking the second number cube, what are the outcomes? 1 through 6. So we're going to make a table here. If I take a 1 and a 1, I roll 1 and 1. If I roll 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. The first one, I roll a 2, then I roll a 1. I roll a 2, then a 2. As you can tell, this is an organized list. Instead of me sitting there grappling and trying to figure out the numbers, and I will forget some numbers, I'm creating an organized list. I'm starting with all the 1s, all the 2s, all the 3s, now all the 4s, and so on. Wait, 1, 2, this is a 3, 4, 4, 4, 5, 4, 6. Roll a 5, then a roll a 1. Roll a 5, then a 2. Roll a 5, then a 3. Roll a 5, then a 4. Roll a 5, then a 5. And so on. So, how many possible outcomes can you get when you roll 2 number cubes? 6 times 6? 36. There are 36 possible outcomes when you roll 2 number cubes and find the sum of it. Tell if each event is certain, likely, unlikely, impossible, or even chance. The sum of the dice being greater than 12. Are any numbers going to be greater than 12? 12 is the max you roll 2. So that's definitely impossible. Rolling 2 2s or rolling 2 4s? Let's see. Rolling 2 2s and 2 4s. It's not impossible, but it's highly unlikely. The sum of the dice being between 2 and 10. So 101 is 2. 10 goes all the way up to here. So that's what you're not going to get these 11 to 12, but most likely it's going to happen. So what's that word called? Most likely it's going to happen. So likely. Not 100%, but likely. Rolling a 1 through 6 on the first die and 1 to 6 on the second. That is definitely certain. That will definitely happen. The sum of the two dice being less than 4. Less than 4. This. There's 3 of them. That's very little of them. It's going to be hard to get that. So it's hard to get it. So not impossible, but pretty much unlikely. So let's keep on going with our stuff. So all right. Looking at your table of possible outcome, what is the probability of rolling a 1 and 1? Let's go back to our table. There's 1 and 1. That's 1 out of 36. That is the probability. The chances of happening is 1 out of 36. Both even numbers. Both numbers have to be even. Let's see. This is even. Both even. This is 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 both even. Both even. Both even. Both even. That is 3, 6, 9 out of 36. We simplify, break it down by 4, which is 1, 4. Rolling a 2 and a 3. How many 2s and 3s? Rolling a 2, then a 3. That's a 2 and a 3. That's a 2 and 3. Any other 2 and 3? Nope. 2 out of 16. 36, I mean, or 118. Both numbers are odd. Well, if both of them are even, should it be the same? Both odds, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the same thing as both numbers are even. So 9 out of 36 or 1 4. And a number that adds to 7. A number that adds to 7. Adds to 7. 1, 2, 3, 4, 5, 6. 6 out of 36. Break it down by 6, 1, 6. So, in the weird horse race that we just did, why does 7 win? As you can tell, when you have 2 number cubes and you roll it and find the sum of it, 7 will occur the most often, unlike any other number. It's right here. There are 6 ways, 6 outcomes to get a rolling of 7. All right, now rope. I already did this already. And we're not going to really go over this. And that's it. So the main thing we learned today is outcomes of rolling 2 number cubes. So you wrote 2 number cubes. There are 1 through 6, 1 through 6. There are 36 possible outcomes you can get from rolling 2 number cubes. From that, you can answer all sorts of questions, like what will the roll probability of the sum of more than 11. It's only 6 and 6, that's 12. It's 1 out of 36 chance.